So friends, let's take our next question, that is question number 28. This section belongs to modern physics. Here the logic gate equivalent to given circuit is. So these are the options, we can solve it pretty easily here. Let's output of this would be A bar, output for this would be B bar, right? And when here you will see the output would be A bar dot B bar and whole bar, because it is the product of A bar and B bar and there's a NOT gate, so it is the relation. So when you simplify this, you will get y is equals to, let's write the solution here. So that is equals to A bar dot B bar whole bar. So when you simplify this, you will get A plus B. So this is result which is very similar to OR gate or result of OR gate. So option 1 is the right answer to this question. Now let's move on to our next question. Here the question you see belongs to section of electromagnetism from chapter Electromagnetic Induction. Here a very long solenoid of radius r is carrying current I as per the relation which is variable. Now counterclockwise current is taken to be positive. A circular conducting coil of radius 2r is placed in equatorial plane of the solenoid and concentric with the solenoid. The current induced in the outer coil is correctly depicted as a function of time by. Now this is a bit of complex question with various graphs. What we want here is that there should be a relation between current and time so that we can understand what should be the answer here, right? So first of all, what is the flux? That will be equal to B into A. What is the magnetic field inside the solenoid? Mu naught Ni, right, into the area of the coil. Now what is I? It is given as, let's see in the question, it is given as kT e power minus alpha t. So I will write I equals to kT e power minus alpha t, right? So now the flux becomes mu naught N A kT e power minus alpha t. So if I want to find the EMF, I will get it as minus of d phi by dt. On differentiating this, I will get minus mu naught N A K. They will come out as they are constants, and differentiating this you will get T into minus alpha e power minus alpha t plus E minus alpha t, right? From here, if you simplify the relation, you will get I as E by R. So that would be, on simplifying, mu naught N A K is taken as common, and you will get from here as T alpha E minus alpha t minus E power minus alpha t, right? Now if you see this relation, what you will get, let's take E minus alpha t as common also. So mu naught N A K E minus alpha t, what is left is alpha t minus 1. This is the value of current. So at t equals to 0, this value will be negative. After some time, as time progresses, this value will become 0 at a point, and after that it will become positive. So our graph should be such that at t equals to 0, it should be negative value of current. After certain time, it should be 0, and then it should be positive. Let's see which is the best suited graph here. So among the 4 options, this cannot be the graph and this cannot be the graph, right? Now what is left is the second and the fourth option. So you can see in the very second case you have our answer. I hope you have understood this question. Now let's move on to the last question of this paper. Now the question you see here belongs to section of electromagnetism again, and it's a pretty simple question but a lengthy one, right? So for point charges minus q plus q and minus q are placed along y-axis at given positions. The magnitude of electric field E is to be found at x-axis at a given position of capital D, where capital D is much greater than small d. Let's start with the solution. So before solution, you need the diagram of same. So as per the question, if you understand that this is the y-axis and this being the x-axis, right? Now we have charges q minus q, then q, and then minus q here, right? I'll extend the line So this line will be like this. Now we have to find the electric field at capital D. So we have 4 charges. Let's connect them like this. Similarly, right? Now the distance, so this is y, the distance here is 2y. So the electric field which is exhibited by this positive charge plus q will be along this direction. Similar with the electric field due to this charge. So together they will form an electric field E1, right? Similarly, the negative charge will have electric field in attractive mode. The resultant will be along this side, along the line, and that would be E2. We have already understood this. Now it's easy to calculate. So let's write down the value of E1 and E2. So on final calculations, you will get E1 as 2qd 4 pi epsilon naught d square plus y square power 3 by 2. And electric field E2 would be 2qd divided by 4 pi epsilon naught d square plus 4y square power 3 by 2. What would be the net electric field? So definitely this is a greater value, this is the smaller value. So I'll say net electric field would be equals to E1 minus E2. When you put down the values, you will get E net as, let's take common, 2qd 4 pi epsilon naught as common. What you are left with is d square plus y square 3 by 2 minus d square plus 4y square 3 by 2, right? From here, when you solve this, you will get 9q y square by 4 pi epsilon naught d power 4, right? I have taken d common out from here. Then this relation will now be written as 9q small d square divided by 4 pi epsilon naught capital D power 4, because y is equal to small d in magnitude as per the question. So we have found our E net proportionality as per the given relation. E net is inversely proportional to capital D power 4. Let's see which is the best suited option there. So among the 4 options given, yes, option number 3 is the right answer for this question. Hope you have understood the solutions very well and they were helpful to you. All the best for your exams. Thank you for watching.